Is there a C?
Is there a C?
Yeah, on ours we have a C.
Some may not change their charge. It is possible in a reaction that there could be something that has the same charge on both sides and it does not change. Now that means that it is neither oxidized nor reduced. Thank you, Victoria. Okay? So if something gets oxidized, something else has to get reduced. You cannot have one without the other. But it is possible, ladies and gentlemen, that there could be something in your reaction that does not change its charge. Then it doesn't matter. We just ignore it. It's not oxidized. It's not reduced. We're looking for what gets oxidized. We're looking for what gets reduced. Are we good?
Yes.
Okay. So here's the charge of iron. 0. Why?
It's a lone element.
Lone element. Here's the charge of oxygen. 0. Why? Lone element. In the compound, though, the charges are no longer 0. To make the compound, they have different charges. Iron is a +3. Oxygen is a -2. Okay? Metals in a compound will always have what kind of charge?
Negative? Positive?
Well, look at it there.
Positive.
Positive. Non-metals in a compound will always have a
Negative.
So, iron went from 0 to +3. How does it go from 0 to +3? I understand that, but what does it have to do to go from having a charge of 0 to suddenly having a charge of +3?
Lose 3 electrons.
Has to lose 3 electrons. And if you're losing electrons, what does that mean?
So you're going through oxidation.
You are going through oxidation. You are going through oxidation. To go from 0 to a +3, you are going through oxidation. Okay? Now, what is oxygen doing here?
I'm going through reduction. Because
Why?
It's losing 2 electrons.
No, it's not losing 2 electrons.
Gaining 2 electrons.
Okay,
My bad.
oxygen is going from 0 to a +2. Well, I'm sorry, a -2, my bad, -2. That means it is becoming more negative. What happens if you go from 0 to -2?
You're losing.
You're gaining
Or
2
Gaining electrons, but your charge is actually going what direction? Left.
Sorry, no, my bad.
What are the only way charges can go? What or what?
Up
Up
and
to
over.
right.
No, not left
Up
or
or
right.
down.
Up or down.
Oh.
So what is happening from 0 to -2?
It's going down.
It's going up. Or down. My bad.
Okay.
Down.
What do we call it when something goes down?
Reduction.
We call it reduction. There's the reduction part, ladies and gentlemen. This charge is actually being reduced. It is undergoing reduction. It is becoming more negative. Okay? So in this example, ladies and gentlemen, in this example, iron undergoes oxidation, oxygen undergoes reduction. Yes, sir.
So both of them have to have like different charges, right? Like both of them can't be negative or both of them
Correct.
positive.
In the compound, one of them, the metal, always going to be positive. The other one, the non-metal, always going to be negative. Now, it is possible, though, for this to happen. Something could start out in a compound over here, in which case it may have a charge of -2. And then over here, it's still in a compound, so it may still have a charge of -2. That's neither one. It's got to be a different charge on one side from the other. Okay? So let's take a look at another one. Actually, this is how we're going to find the charge of a transition metal. How we're going to find the charge of a metal when it's in a compound. Because again, in this one, can we find the charge of iron by looking at it up here?
Nope.
No, we cannot. It is in an area of the periodic table right there where there is no charge above or below that. So what we have to do is find our charge another way, ladies and gentlemen, and this is how we find the charge. Yes, go ahead.
Isn't it like we take the two bottom numbers and then we do like a little cross thing?
Not always, because remember, we did do the crisscross method to get the charges, but sometimes after you did the crisscross method, what did you do to those numbers that you brought down? Anybody remember? Sometimes you had to reduce them. So it isn't always as easy as just uncrossing them. It isn't always that easy. But there is a way we can find the charge on any transition metal. And that is this. We know that the total charge of a compound, this compound always has to be what? Nope. Nope.
Neutral.
0. Neutral. So when we write a compound, we're writing the compound so that its total charge is 0. Now, we do not know the charge of chromium here. That's a problem. But we do know the charge of what? Oxygen. What's the charge of oxygen?
Neutral. No? -2.
-1.
You just said it was neutral though. -2.
When did I say it was neutral? I said the compound was neutral.
Oh, okay.
The compound was neutral.
It's
What's
the same. It has to be the same, right? Because then it cancels each other out. Oh, right? Because the compound's neutral. So
They don't have to have the same charge. Why? Because there aren't the same amounts of each. Overall, the total charge needs to be 0. You are correct. But let's get there. Now, to get there, I need to know what the charge of oxygen is.
It's -2.
Yeah. We go back to our periodic table, ladies and gentlemen. Here's oxygen. We go up to the top, its charge is a -2. That is always the case. Oxygen is always a -2. And in this compound, there are 5 of them. So if you have 5 times -2, what do you get? You get -10. Which means the only way the total charge can be 0 is if the positive side of this has to be what number?
10.
+10, right? Now, well, I don't know what the charge is here. I do know how many are in the compound. How many? 2. So here's the question. What charge times 2 gives us a +10? Charge is a +5. So we are working our way backwards. Now, here's the thing. If it were calcium in the compound, what would the charge be?
+2.
+2. If it were rubidium in the compound, what would the charge be?
1.
+1. If it's aluminum, what's the charge going to be?
+3.
+3. If it's zinc, what's the charge going to be? You're sitting there going, Mr. Brand, you're pointing to one in the area where we can't tell. I would have hoped Ethan would have jumped in here. What?
It's probably not on a periodic table anymore.
It used to be on your periodic table, ladies and gentlemen, that I told you zinc was always a +2.
Right.
What's silver always?
Plus. Oh, yeah, +4. -4.
Okay, well, it's a metal, right? Metals always have what charge? Positive. Silver was a +1. Always a +1. So some elements we can tell based on what group they're in. I gave you zinc and I gave you silver, that they were both zinc a +2, silver a +1. Okay?
It was 10.
All right, so now let's take a look at this one, ladies and gentlemen. Okay? All right, so we don't know what the charge of iron is because it's in an area of the periodic table where we cannot tell. What do we know about phosphorus, though? What do we know about phosphorus?
Phosphorus is a -3.
Phosphorus is a -3. How many of them are there here?
2.
There are 2 of them, and they are -3. So what does that mean for the total charge of phosphorus?
It's -6.
-6. So the only way these total charges can equal 0 is if what is the total charge here? plus 6. Now again, I still don't know the charge here, but I do know how many are in this compound. How many?
3.
Okay, so what number plus 3, or I'm sorry, strike that. What charge times 3 will give us a plus 6?
Plus 2.
There you go. You can find the charge, ladies and gentlemen. You can find the charge. Questions?
Nope.
Now, here's the honest to goodness truth. Even if you don't know the exact charge, what is the charge of a metal in a compound always? Plus something. What is the charge of the nonmetal? Minus something. That is almost always good enough for you to at least figure out which one is oxidized or reduced. Okay? So let me show you. Okay? Oops. I guess we're doing one more.
Okay.
So
Whoa.
2 sulfurs. What's the charge at what?
The Mn doesn't have a number by it.
Doesn't have to. It doesn't have to. The only reason we're putting numbers down here is why?
Show much there, isn't it?
Yeah. Maybe there only needs to be one of it. What's the charge on each sulfur?
-2.
-2. Again, if you have updated your periodic table, ladies and gentlemen, if you have gotten a new one, you may want to write these charges down on the bottom here, 1 plus 1 plus 2 plus 3 plus 4. And on the top, you may want to write -4, -3, -2, -1, and 0.
I did that.
Okay, just so that you have them. Okay? So 2 -2s would be what for a total charge? Two times -2?
-4.
-4. So what does the total positive charge have to be?
Plus 4.
Plus 4. How many of them are in here? 1. So what has to be its charge? Has to be a plus 4. Has to be a plus 4. Okay? Has to be a plus 4.
I got you.
All right, try to find the charge of vanadium, please, ladies and gentlemen. Try to find the charge of vanadium. If you need a scratch piece of paper, I have them over here. You can come up and grab one. If you need one, raise your hand. I'll give you one. You can work it on your periodic table. Matters not to me.
Positive 15.
Remember, while we can't know the charge of some metals, we always know the charge of the nonmetals. Always. Those don't change their charge. So who's got an answer for me?
5.
What?
The charge of the non-metal is 5. Or the V. Whatever it's called. I don't know what the V is.
Vanadium. You can just say V, that's fine.
V or vanadium is the charge of 5.
Positive or negative?
Positive.
Okay? So let's check. There are 5 nitrogens. Each one has a charge of -3. Meaning our total down here is -15. Meaning this has to be plus 15. Since there are 3 of them there, what charge times 3 is positive 15? Plus 5. Now, this one, you could just uncrisscross them. Right? You could. Here you couldn't. Why? Because we ended up reducing this one. But again, the metal is still what kind of charge? And the non-metal is still negative. Okay? Non-metal is still negative. All right. So again, ladies and gentlemen, just a quick review here. Group 1 plus 1. By the way, that term that I gave you the other day, oxidation number, this I like to use the term charge, but this could also be called the oxidation number. Oxidation number is the apparent charge. And what they mean by apparent is the only way this can be 0 is if this is acting like a +4. So that is what they mean by its apparent charge or its oxidation number. Okay? All right. So again, ladies and gentlemen, here are your charges. By the way, in the carbon family, how do we know if it's a +4 or a -4?
So you have the line, the ones that are like, so carbon, and then the other one would be -4, and then the other, so one would be, or the carbon and the other one would be -4, and then the other one would be +4.
Okay, just to clarify, because you did a nice job of explaining that, but carbon and silicon, that's the other one you're referring to, are both -4. Why?
Because they're above that.
Which makes them?
Positive.
No.
Or negative.
Because they are what kind of elements?
They're metal.
No,
They're
they're non-metals. You're right about silicon. It is a metalloid. But more important, it is a non-metal, so non-metals have a negative charge. Now, you said carbon and the other one, and then the other ones. Let's make sure we understand. Carbon and silicon are the -4. Down below, germanium, tin, lead, flovium. Those are the +4 ones because they are, which makes them
Or metal.
metals. Makes them metals. Okay? Makes them metals. All right. So, let's try this, ladies and gentlemen. We told you that the reactions that you did in the lab that one time were all redox. Okay? So let's take a look at one of those reactions, ladies and gentlemen. So here we go. We took copper metal plus silver nitrate and we mixed them. And what we ended up with was copper nitrate plus silver metal. Okay? Now, to balance this, we would put a 2 here. I need to move this. And a 2 here. Questions? All right. What do we know about the charges of lone elements?
They're neutral.
They're 0. So where are your lone elements in this reaction? The copper at the start.
And then the silver at the end.
The silver at the end. Right? Those are lone elements. They will have a charge of 0. Any questions on that? What's the charge of this NO3 group? Look on the back of your periodic table and tell me what the charge of this NO3 group is. -1. And over here, it's still a -1. Okay? Now, what is the charge of silver always?
1.
+1. What is the charge of copper in this compound?
Hold on. 3.
No.
Okay.
How many of these NO3 groups? How many? No. How many outside parentheses? 2. What's the charge of each group?
3.
What's the charge of each group? It's written there. Come on, help me out here, people. -1. 2 -1s will have a charge of? -2. What does the total charge of a compound always need to equal, Brianna? Total charge of a compound. We were just doing these on those last couple slides. What's the total charge always need to equal? 0. So the only way this can equal 0 is if this has to have what total charge? The metal. Positive 2. Well, how many of them are in this compound? 1. So what has to be its charge? Positive 2. Let's say positive 2 just so we don't get it confused. I understand. Well, I understand it's a metal, but we're talking about all these charges up here. Let's list it as a positive 2. Okay? Don't look at me like that, Kiana. Okay, good. So now, ladies and gentlemen, what's changed charge here? What is changed charge here?
What changed?
Yeah. Look from one side of the equation to the other. What elements have changed charge?
The CU.
Cu went from 0 to what?
Positive 2.
Okay. And also the Ag went from +1 to 0. Now what happened with the NO3? It stayed the same. So is NO3 reduced or oxidized? So neither. This is the one where, okay, sometimes things will not change their charge, right? Okay, so copper went from 0 to +2. Silver went from +1 to 0. Which one of those is oxidized? Which one of those is reduced?
Copper is oxidized and silver is reduced.
Why is copper oxidized?
Because it lost 2 electrons.
Why? Because it loses electrons. It becomes more positive. Good. So what became more negative? Ag. Ag undergoes reduction. It gains electrons. It becomes more negative. Now, what do we mean by more negative? Well, it went from +1 to 0. Copper went from 0 to +2. That is what I mean when we say we can identify what is oxidized and what is reduced in a chemical reaction. By finding out which one loses electrons, becomes more positive, that one undergoes oxidation. By finding out which one gains electrons and becomes more negative, that is the one that undergoes reduction. Questions? All right, clear your desks of everything except for your periodic tables and your computers, ladies and gentlemen. You should not need calculators for this quiz.
You go next door.
All right, Helen's not here. Alexa's not here. And Jennifer. Jen's not All right, ladies and gentlemen, I just posted the quiz online for you. Here it is, ladies and gentlemen. You can go ahead and get going on it, please. Okay? So let's go. Gentlemen, quit yapping. Start working, please. If you have questions during the quiz, ladies and gentlemen, please, please, please call me over and I will be happy to help you reinterpret or rephrase the question for you.